Hello everyone. I hope you guys can hear me. Those who are on YouTube, if you can confirm whether you can hear me or not, it will be great. Let me share the meeting invite as well, so that if anyone wanted to join the webinar, you guys can join the webinar as well. Here is the webinar link. Let me start sharing my screen. Let me also broadcast in my groups so that people from my group join. Can someone from YouTube confirm whether you are able to? 1 minute, okay. Yeah, it is streaming. So let me actually broadcast the message and also validate whether people on Meetup can see. Let me see if people can meet on meetup.com can see me or not. I'm just making sure that everything is working as expected before we get started. Yeah, now everything is fine. Let's get started. First of all, thank you very much for attending this session. I hope you guys can hear me, whoever is joining on YouTube. Once again, I'm reiterating, I have just posted the link as part of the YouTube live streaming chat about the webinar. You can join the webinar and you can ask any questions at any point in time you have. I'll be taking the questions towards the end, but you can post the questions whenever you have questions in your mind. I might curate some questions and only answer some of them before we wrap up the session. This is the continuation to yesterday's meeting. If any one of you missed the yesterday's meeting, as part of the description in the YouTube video link, in the YouTube video page, you have a link by name part 1, and you should be able to go through yesterday's meeting by clicking on this. I'll also be sharing the deck. Even I have written the article and published in Medium, and I posted in yesterday's meeting. Even for today's one also, I will do the same thing once we wrap up this one. Now, the today's agenda is primarily to reiterate the roadmap to become a data engineer, and then we'll go to the workshop to understand which skills should be learned at what level. I'm not only talking about which skills should be learned, but also I'm going to talk about up to what level one should be proficient to succeed as a data engineer. So first, I will go with the roadmap. The roadmap. Let me see. This is not the one. Okay, I haven't written here, but I will explain. So roadmap to become data engineer is primarily to start with SQL. You should be very comfortable with SQL. You have to be knowing advanced SQL. Also, you should be knowing the functions which deal with JSON data, because you have to deal with semi-structured data. Almost 10 to 15% of the use cases when it comes to data engineering. And you should be knowing all the functions that are relevant, manipulating JSON type data using appropriate functions using SQL. So you have to learn up to the level of manipulating JSON on top of advanced SQL, which covers ranking, cumulative aggregations, all those things. Okay, so these are the details which you can use as reference. You have to start with SQL. One need to have extensive knowledge of SQL. But if you are not able to understand SQL advanced concepts, don't worry too much to begin with. And just have a broader knowledge of SQL. Be comfortable with the terms if you are an entry-level professional. If you are a seasoned ETL developer, you should be knowing SQL already up to analytic functions or windowing functions. Even though you might not be comfortable about those, you should be hearing about those. Now you need to make sure you are really comfortable about those as well. More than that, more than ranking and analytic functions, it is very, very important for you to focus on manipulating the JSON. Why manipulating JSON is more important than analytic functions or windowing functions? Typically, the analytic functions such as rank, dense rank, etc., is taking care at the reporting layer, not at the data processing layer. Sometimes we might deal at data processing layer, but many times we deal with those things at a reporting layer. But to troubleshoot the issues, to make sure the data is of good quality, it is giving ranking as per the expectations and all, you might have to run those queries once in a while. But when it comes to manipulating JSON, even while developing the ETL workflows or pipelines, you have to know how to manipulate the data. Today, we'll be seeing a demo so that you understand what I'm talking about. You need to make sure you gain enough proficiency of Python at a broader level, especially data processing frameworks such as Pandas, Apache Spark. If you are an experienced professional, focus on breadth than depth of Python. If you just focus on depth in Python, and even when it comes to breadth, you need to have a scope. You should not go beyond that scope. The primary modules within that scope are nothing but Pandas and Spark. On top of it, you should know how to manipulate JSON using Python also. So there are around 10 to 12 modules, out of which Pandas and Spark are the major ones, which you should be familiar with as an experienced professional to begin with. Don't try to develop complex algorithms just to become good at programming. It will not take you anywhere. It will demotivate, and eventually you might end up giving up. So focus on breadth and try to understand Python from the ETL perspective, leveraging data processing frameworks such as Pandas, Spark, etc., rather than worrying too much about depth. Then you have to focus on cloud essentials based on cloud platform of your choice. It can be AWS, followed by Azure, followed by GCP. I would suggest AWS or Azure for most of the enterprise seasoned ETL developers rather than GCP, because GCP is more popular in the non-enterprise world compared to enterprise world. You have to understand key data warehousing concepts. We'll also conduct a live workshop on key data warehousing concepts very soon. If you are interested to attend that session about key data warehousing concepts, it will be a free session. Feel free to subscribe to our channel and also hit on the notification icon. Whenever we announce that, you will get a notification about it, and you can attend and you can learn more about data warehousing key concepts in data warehousing. Also, you should be familiar about BI terms such as reports, dashboards, etc. But you don't need to be a very good BI or analytics developer. When I say BI, you don't need to sit and develop complex reports and dashboards, catering the requirements, catering the requirements of the business, whatever they have given. BI developer is a bit specialized role. It requires more domain expertise than technical expertise. You also need to have technical expertise, but domain expertise also matters when it comes to BI developer type of roles. Learn how to build end-to-end pipelines and focus on integration of services and applications using REST APIs as well as SDKs or CDKs or REST APIs. Again, we'll be simulating this for our today's workshop, and I'll focus on how to build end-to-end pipeline. Then ability to troubleshoot issues related to job values and data quality. So you should be in a position to troubleshoot the issues where it is going wrong. To make sure you can troubleshoot the issues, you also need to make sure you actually, once again, I'm reiterating, from the perspective of ability to troubleshoot the issues, you also should know how to log relevant information to troubleshoot the issues. Without logging relevant information as part of your pipelines, it will be tough for you itself to troubleshoot the issues. From that aspect, troubleshooting the issues related to job values is a two-pronged approach. You should be able to troubleshoot the issues, and also you should make sure that your pipelines are actually providing required insights to troubleshoot the issues. Also, you should be very comfortable in understanding the data quality against the requirements so that you develop in a reliable fashion. Finally, as you gain experience, you should be in a position to tune the performance. First of all, you should be in a position to identify where the gaps are. Sometimes you might not have the benchmark to compare and see whether it is performing as per the expectations or not. So you really need to understand how to proactively tune the performance of your pipelines, of your queries, etc. If you have a benchmark, it is easier to use that as reference and try for performance tuning. But if there is no benchmark, that's where your real engineering abilities comes out. You really need to understand whether it is performing as efficiently as it should be, and then you have to come up with a solution. So this is the roadmap to be a data engineer. If it is vague, don't worry too much about it. It's not that complicated if you're an entry-level professional. All the seasoned ETL developers, PL SQL developers, data developers, even though they might not focus in these areas, from this perspective, they should be familiar about all this. Okay. That being said, let me also stream my video. Yeah, now you should be able to see me. Okay. Now let's get into the deck. That is the roadmap which I want to reiterate before getting into today's session. Now let's get started. I would like to have a long-term traceable journey with you guys. So there are multiple ways to stay connected with me. I will be sharing the link here in the chat. I will also give some time for you to actually go to this link and go to second or third slide at this juncture, and subscribe to YouTube channel. Follow us on LinkedIn page if you are interested to follow ITversity on LinkedIn. You can also sign up for our newsletter. It's a very simple Google form. Let me click on this. It will capture the information, and it is primarily to share our low-cost Udemy coupons, monthly newsletter with important updates, job opportunities, and also notifications about workshops or webinars. If you want to be part of this, make sure you fill this, and you will get the required notifications based upon your preference, so that we don't spam you if you are not interested in certain areas. So make sure you spend some time, understand the questions, and try to fill it. Also, you can visit my Udemy profile and understand more about me in case if you are curious and new to ITversity, what all courses we have published. There are quite a few courses around data engineering, and we'll continue publishing quite a lot of courses in future around data engineering on Udemy. And also we are conducting the guided programs. I will talk more about guided programs towards the end of the session. So I'll pause here for a few minutes. Make sure you go to these links in the deck that is shared. Either you can go to 30th slide, or it is in third or fourth slide at the top. So either of the ones you can use. If it is through Medium, again, as part of the Medium, at the beginning of each of the part 1, part 2 articles, we will provide this information. If you watch this outside the live stream, you can use that Medium article as reference, and you should be able to fill the details. Okay, so that being said, while you fill, let me actually broadcast about this session on LinkedIn, so that people from LinkedIn might end up joining this meeting as well. Okay, so that being said, let's get into the details of today's session. So let me reiterate the problem statement. I have spoken about this yesterday also. It is primarily based on running analytics on top of Salesforce leads of sales data using the data lake and the data engineering pipelines. We will get the data ingested from Salesforce into the bronze layer. Data will be in semi-structured format. We will try to apply required transformations and store the data into data warehouse. The data should be well structured and should be ready for reporting. We will again review the data before actually getting into the workshop. Even reviewing the data is part of the workshop. Even when you get into the project, once you get the requirements, you should spend some time in analyzing the data and understand the characteristics of the data. Now, when it comes to design, this is how it will be if you are going to use AWS native services. So AWS provides something called as Amazon Airflow. I have already given a brief overview about Amazon Airflow. I will reiterate once again so that we have end-to-end details about this pipeline. So from Salesforce, Also, before getting into there, let me go back to the slide where we talk about the roadmap, right? So if you look at the roadmap, oh, it's not here. It's actually in Medium article. Yeah, let me go to that roadmap. One of the key thing is learn how to build end-to-end data pipelines and focus on integration of services and applications using REST APIs as well as SDKs or CDKs or REST APIs. Or even applications. So Amazon Airflow is one of the applications which will take care of integration of standard applications like Salesforce or standard platforms like Salesforce, ServiceNow, Slack, etc. So using their APIs, Amazon have built this Airflow. You don't need to worry too much about low-level coding integrating with these things. But in many places, we might even have to use low-level APIs. And for that, you should be using Python as programming language. So you need to be familiar about how to build pipelines using sources which are behind REST APIs or SDKs or CDKs on top of REST APIs or applications like Airflow. So this actually falls under this category, means whatever use case which we are going to explore, especially from the perspective of data ingestion from source into the data lake, will fall under this category. Now, let me go back to the slide. So from Salesforce, using Airflow, you can ingest data into a data lake. When it comes to AWS, S3 is the data lake. If it is Azure, ADLS will be data lake. If it is Databricks, which is a cloud agnostic platform, or Snowflake, which is another cloud agnostic platform. In those scenarios, they have an abstraction. Databricks have something called as DBFS, Databricks File System, which is the abstraction on top of S3 on AWS and ADLS on Azure. Okay. So even if you use Databricks for your data processing, if it is on AWS, still you will be ingesting data into S3 only via Airflow. So when it comes to ingesting data into S3, you will be having options about which file format you should use, what is the delimiter, all those things will be configurable. Once you configure those things in Airflow, you should be able to schedule in such a way that the incremental data from the source, depending upon the abilities that are made available to Airflow by the source, will be ingested into data lake on regular basis. We can use something called as events bridge to schedule. Okay, so data from Salesforce will continuously flow into the S3 on regular intervals. And from there, depending upon the data volume, we have to choose whether we wanted to go with the Lambda or AWS EMR. If it is AWS Stack, you can also use Glue. Glue is also Spark-based engine only, but I prefer to use AWS EMR because it uses open source Spark. Whereas with respect to Glue, it doesn't use open source Spark, and hence I don't prefer Glue unless and until the client wants to implement using Glue. Then data will be processed and ingested into S3, which is another location within S3. Once the data is exposed, once the processed data is placed in S3, then we can leverage any database to build reports and dashboards. It can be Amazon Redshift if it is the AWS Stack. It can be Snowflake if you want to go with the cloud agnostic data warehouse. It can be Athena, which is again another AWS service. Like that, there are a number of services which you can use. If it is Databricks, you can also use Databricks SQL, which uses something called as Photon engine, which fine-tune the performance from the reporting perspective, and you should be able to build the reports and dashboards. Okay. So when it comes to Redshift, you might have to, sometimes for the performance of reports and dashboards, you might have to copy the data into the Redshift tables, and then you have to report. Whereas with the Databricks SQL build something called as Photon, which runs on top of S3 directly. So you don't need to move the data into the data warehouse if you are using Databricks SQL. Don't worry too much if you don't understand all these nuances at this juncture, but this is the design if you want to go with AWS native, and this is the design if you want to go with Databricks. As of now, I'll be demonstrating using AWS native. In future, I'll also come up with a lot of material around Databricks once I'm done with AWS Data Analytics services. Already we have gone through the overview of Salesforce and AWS Airflow. I will reiterate once again. Then we'll review CSV data with semi-structured or JSON fields. So I have simulated I have created a simulated dataset, which is similar to what Airflow actually ingest into S3. This is based upon one of the students' feedback in recent weeks, who have given some data as reference, which is generated by Airflow. As I should not expose the original data itself, I have come up with a simulated data set and I have ingested into S3. As of now, if I have to build a pipeline from Salesforce via Airflow into S3, it will be difficult for me. Even in your projects also, while waiting for the client to actually provide you the data in S3, if your scope is primarily to build the pipeline, configuring Airflow will be only 2 to 3% of the overall project. It will not be big deal. If you can actually get the data the way it will be ingested into S3 by talking to the client, and if you upload to S3 directly, you can take care of the development of the data pipeline. And then once the client provide you the data, you might have to rebuild a few things depending upon the quality differences between the simulated data and original data, and you can take it further. You don't need to wait until you are integrated with the Salesforce to take care of the rest of the development of your pipeline. So I'm actually simulating that itself. So I got the data as reference and I have ingested into S3. I will walk you through the data once again and we'll take it further. Salesforce is nothing but a popular CRM, which is used by almost all the enterprises today to take care of leads and sales management within the organization, and also to manage the customer relationship. Okay. And AWS Airflow, let me open as part of the AWS console. You see, AWS Airflow, Amazon Airflow can not only get the data from Salesforce, we can also get data from ServiceNow, Slack, Marketo, many other sources. Okay, it primarily uses their SDKs and CDKs, and they have built a solution out of the box so that you don't need to worry too much about coding while integrating with the standard sources. That is the brief overview about Airflow. Let me do this. Let me move this here. Now let's review the CSV data once again. It contains a couple of semi-structured fields. I will go to the details and then we'll take it further. Already I have copied the data into my local file system. The location is nothing but this one, downloads addresses.csv. Now let me actually say view, then tilde / downloads addresses.csv. You see, if you are new to CSV files, you might not be able to understand it properly unless and until you spend some time and go to the details. So CSV files are nothing but text files. They are text files, and each line in the file will represent a record in a table or a record from the REST API call. Okay. Some CSV files might have header. CSV stands for comma separated variable length record. CSV means comma separated variable length. Even though we call them as CSV, many times we might use other type of separators also. It can be pipe, it can be some special character as control A, and so forth. Okay, and some CSV files will have headers. Some CSV files will not have headers. So before actually building any pipelines on top of your CSV data, you need to review these things. What is the separator? In this case, the separator is nothing but comma. Whether the CSV file have header or not. You can see there are columns or names of the columns as part of the first line, which means it is nothing but a header. On top of these things, you also need to see whether there are any column values which have comma in it. So in this case, comma is supposed to be a delimiter, right? You also need to spend some time and understand whether one of the column value have comma in it. If it have comma in it, if comma is a separator, there is a possibility that that column value is split to 2. Let me give you an example and I'll take it further. So this is ID, there is no comma in it. This is first name, there is no comma, last name, then email ID, okay, then gender, then IP address. Then you have something called as phone numbers. Phone numbers start from here and end here. And if you look at it, it have a comma in between. So unless and until you deal with it separately, this will be split into 2 parts by default, if you consider it as a CSV. And also we have the final column address, which start here and end here. And even if you look at this, there are quite a few commas in this. Okay. Sorry. Let me come out of it. Okay, so the first comma is here in address. The second comma is here. The third comma is here. Right? There are 3 commas in it. So it will be split into 4 fields if you directly process the comma as delimiter. To make sure when column values have commas are dealt properly, what it does is, what CSV files, the way we store the data in CSV files is by enclosing the entire column value whenever there is the separator in it using some character. In this case, it is nothing but double quote. So this is the beginning double quote, and this is the ending double quote for this entire 4 numbers. Okay, so this is nothing but enclosing your column values which have separators in them using some special character. Typically we use the double quote. Even for the address also, if you see, address starts from here and end here, and you see this entire thing is enclosed by double quotes. Okay, now you have additional double quotes, right? Why we have double quotes here? If you don't have 2 double quotes, this one will be considered as an enclosing string. Okay, and then it will start throwing errors because there is no double quote for street. It can cause weird kind of issues. You really need to understand how the data is represented in the CSV files. Now, when you have enclosed a string in double quotes like this, if your string itself have double quotes again, why we need to have double quotes here? Because when it comes to JSON, any string value should be represented in double quotes only. So you can't avoid double quotes for keys and values related to the JSON. This is nothing but a well-formed JSON string. Whatever you are seeing with respect to address are nothing but well-formed JSON strings. Okay. Now, yeah, the string values, whether it is a key-related value or value-related value, whether you are on the name of the attribute or value of the attribute. If it is a string, you have to enclose in double quotes. So this this double quote is related to beginning of the name of the attribute, and this double quote is ending for the name of the attribute. Because the enclosing character is also double quotes here, okay, you need to make sure these double quotes are escaped. Okay, again, when it comes to escaping, there are multiple ways to escape. Many times you will see backward slash to escape, but there are scenarios where the escape characters might be double quotes itself. Okay, it is very, very important to understand this. So as both the phone numbers as well as addresses have commas in them, the column values, the values related to phone numbers and addresses have commas in them. We have to enclose them with some character. We have enclosed those with double quotes. When it comes to both phone numbers as well as address, the values are strings, JSON strings, and hence they are supposed to be enclosed in double quotes. Because the main value is enclosed in double quote, how to deal with these double quotes which are already there in the values? We have to escape. How to escape? You can either use the double quote as an escape character, or backward slash as escape character, or whatever character you wanted to use as escape character, you can use it and take it further. Now, once you have, once you escape the double quotes like this, when you have inner values, then this entire thing will be considered as one column value, whatever is there in these double quotes. Same is the case with here. So it is very important for you to understand the data characteristics, and you have to take it further. Now, we have semi-structured data in the form of phone numbers and also the address. We need to make sure we can use the appropriate APIs to process the data. It is very, very important. Okay, so that being said, if you are liking the content, if you join through YouTube, make sure you click on the like button, and also feel free to share with your friends if there are few people in our network who fall in this category of ETL developers, PL SQL developers, etc. To actually follow, and also if they're interested, they can sign up for our courses. We'll be conducting onboarding sessions very soon on regular basis. So anytime anyone wants to become a data engineer, they can be onboarded. And also we have courses on Udemy, which people can take and take it further. Now let me come out of it. I hope everyone is clear about the characteristics of the data. Now let's go to the next step. We need to make sure the files are uploaded to bronze layer of data lake, simulating data ingestion from Salesforce via AWS Airflow. Already I have the files in S3. You can see I have changed the location a little bit, representing the multi-layered architecture. So we are going to follow the multi-layered architecture. Let's assume this is a bronze layer and this is gold layer. We'll be placing files in the bronze layer first, and then we'll process and write to gold layer. To mimic that, I have created something called as bronze under A retail. In the bronze, I have created a folder by name addresses. You see here. Actually, I'll be using SF leads, not addresses. Okay, bronze and then SF leads. SF leads means Salesforce leads, because this is simulated Salesforce data. In that, we have addresses folder. You can see here. In that, we have the addresses.csv. So we have the files here. Now, you should not be using Spark itself because it is hot. So many times as engineers, we will have the bias. More than coming up with the solution for the organization, it is many times it can be unknowing. I mean, you might not be aware of it. It might not be a conscious decision. Sometimes some people actually take the conscious decision also. They give priority to themselves and they try to come up with the solution based upon their zeal to learn rather than the optimal solution for the client. Many times, even though they know a particular approach is not the right approach, but as they are comfortable with that particular approach, than the efficient approach, they just stick to it. Okay, so in this case, first you need to understand additional characteristics of the data. Already we have gone through the details about the format of the file, which is nothing but text file with a comma as the delimiter. On top of it, we have gone through the details about whether the file have header or not. If there is a commas in the actual column values, if yes, how they're enclosed, and also if they have a enclosing character in the column values, how they're escaped. We have understood all those details. Now, when it comes to designing the pipeline, the choice is between pure play Python pandas approach and the Spark SQL or Spark based approach. You have to first evaluate client requirement. If the client say, I'll be sending a few thousands of leads data every day, which you can ingest into the data lake and generate the reports. Okay, few thousands is not a big number. It doesn't make sense to actually build a Spark-based pipeline to ingest this data, to process this data and push it into the reporting layer. Okay, there might be few exceptions here and there, but the general tendency should be, because the data volume is not very high, you should not just go and blindly implement using Spark on EMR. Okay, by the time it actually brings up the Spark, you can actually brings up the EMR cluster to process your data, even if you use the EMR serverless, which is quite fast. If it is a low volume data which is coming every day, you will be done with the ingestion. You will be done with processing the data and writing it to the reporting layer, which is nothing but this one. So first you need to understand the size, the number of data points which you are trying to get the data from source. For example, from Salesforce, we call them as objects. We get the data from the objects. What all different objects from which we are trying to get the data? What is the volume we are getting? Based upon these things, we have to decide whether to go with simpler solutions like using Python pandas. If there is a moderate size or huge volumes of data, then we have to brainstorm and decide whether we want to go with EMR or if there is any alternative solution. Okay, now when it comes to this one, I have close to 10,000 records. Let me see. Yeah, this is the file which I have downloaded. I have close to 10,000 records. Many people might feel that, okay, 10,000 is a big number, but 10,000 is a very small number. On top of it, the number of records, you can also check the size of the dataset. This dataset is only 2 MB. For this, if you try to use EMR-based approach, it will be an overkill. You will end up wasting a lot of money for your client or for your employer. So you can actually come up with the solution using pandas, or there might be better alternatives also where you don't need to even code. Okay, because Salesforce is a very standard application. They provide leads in a very standard way. Depending upon the industry specific lead management, there might be out of the box solutions also. You might end up using those even to transform the data. But in the worst case, if you have to code, you can code using pandas, leveraging Lambda if the data volume is smaller. If the data volume is bigger, then you have to use Spark based approach. Okay, so first I will for this demo purpose, I'll be using same dataset with both Lambda as well as EMR. But in your actual project, you have to really understand the data a little bit better. Not only the sample data which will be provided to you, you have to think from the requirements perspective. Means you have to talk with the business to understand what is the size of the data, what are the number of objects from which data will be generated, and we need to capture the size at each and every object level. Okay. So that being said, now let me go to the details about how to come up with a solution using pandas. Okay. Here I am going to set up a project. Let me see if I have, yeah, my Visual Studio Code is integrated. Let me close this. I don't want to use this one. Let me say SF leads. So I typically use Visual Studio Code for any Python development. Okay. In this case, the file is already in S3. You don't need to do anything fancy to actually get the data from S3 into the pandas data frame. Within a couple of lines of the code, you should be able to get the data into something called as pandas data frame. Using pandas data frame, you should be able to manipulate the data very easily. Okay. So in this case, I'm actually creating a file saying JSON SF leads transform.iponb. Okay, I'll be demonstrating using Jupyter based approach, but I'll be deploying whatever logic that is going to be used as a Lambda function. Already I have a Lambda function. I'll run it directly and I'll show whether it is working as expected or not. But before getting into running the Lambda function, I want to make sure I develop the actual logic using Python that is set up locally on my machine. And if you are not sure about the complete process of development of Lambda functions to take care of use cases like this, we already have courses on those, both on our platform as well as Udemy. You should be able to sign up and you can take it further. Okay, now first of all, I need to make sure I have, let me see, Python 3. I need to make sure I have pandas set up. Let me actually create a Python virtual environment by saying Python 3.9-m venv sfl-venv. So this is called as Python virtual environment. It is primarily to manage the dependencies. Don't worry too much if you are completely new to Python. Let me move forward and let me take care of few things here. So I'm saying source SSL venv bin activate. Even when it comes to the development process, these steps are one-time steps, and you will be getting instructions in the form of README or some document. or a confident page, and you should be able to follow those instructions and set up the environment. Now the virtual environment is activated. We need to make sure we install pandas, Boto3, S3FS, FS spec. These two are the ones which actually integrate pandas, which is the primarily data processing framework. Boto3, which is nothing but a important library to interact with AWS to manage the services in AWS. So if you want to be AWS based data engineer, then you have to be very proficient about Boto3. It is as important as learning pandas as well as PySpark. And then only you will be able to work with AWS effectively. Otherwise, you will be coming up with half-baked solution. Boto3 is also very, very important for you to pick up as a key Python-based skill to develop data pipelines leveraging AWS services. Now let me run it. It will take care of installing all these dependencies. Because we not only installed Boto3 and pandas, but also FSSpec and S3FS, we will be able to directly interact with files in S3 as if they're in local file system. Okay, you don't need to write any code to read the file in AWS S3 to process the data in that file. Let me show you so that you understand what I'm talking about here. I'll also create one file here. The file name is nothing but .env. It is because I have to set one environment variable so that I work against appropriate AWS account. Okay, now let me save it. Now let me go to the notebook. Import pandas as PD. I might have to change the virtual environment here. Yeah, now it will work. Okay, it is still installing some extension. Yeah, now you see the pandas is imported. Just give me a minute. Then you can actually say df equal to pd dot read underscore CSV because ours is the CSV data, right? Now we can actually give the path. The path is nothing but S3 colon / a retail, then bronze, then SF leads. Let me check whether I'm giving the right path or not. Yeah, SF leads, then addresses, then address.csv. Okay, so here I'm not writing any code to read the data from the file and then bring a structure to it. I'm just writing one line of code after importing pandas as PD. And now the data frame is being created. There seems to be some issue here. Okay. File not found. Yeah, it is addresses, not address. Now you see, without me writing any code to read the data from the file, it is read successfully. And also the data have a structure to it. You can see here, we have ID, first name, last name, then email, then gender, then IP address, then phone numbers, then address. So because we have those enclosing double quote characters when we have comma in our phone number and address, and also as double quotes are escaped by double quotes itself, you can see the data is as per the expectations. You can validate only the phone numbers by saying df of phone numbers like this. In the similar manner, you can also validate address. So it is automatically taken care of. The entire logic is there in this function call. So you haven't written any code for this. You just attempted to create the data frame, and it have created as per the expectations. Now the requirement is as we have semi-structured data, we want to define a proper structure to this data. one of the ways to deal with so that we can actually use standard SQL to report against these column values is as phone numbers is of type JSON array. We might want to explode them into individual records. So this record should be exploded into 2. This record should be exploded into 3, so and so forth. Okay. So the way you can do it is like this. So there is something called as apply function on top of pandas data frames or pandas series objects. You should be able to use the appropriate function, and it will take care of one minute. It will take care of exploding it. However, to explode it, first we need to make sure we take care of few things. I will explain it in a bit detail very soon. So in this case, phone numbers is of type JSON array. First, we need to make sure it is interpreted as a JSON, and then we need to make sure it is exploded to individual records. Okay. So the way you can interpret this as JSON and convert to other formats is by using a module called as JSON. Okay. So it have a function called as load-s. If you pass a JSON string to it, it will convert to Python data structure. Python have 2 data structures which are related to JSON. They are nothing but Python list and Python dict. So this can be interpreted as Python list by using the JSON.load-s. So let me show you what I'm talking about here. Let me first create a string s equal to, okay. Let me paste. This should be enclosed in double quotes, right? And also these should be escaped with double quotes. Let me specify 2 double quotes for this. Now it is a string which contain a JSON array in it. Okay. I already imported JSON. I can say JSON.load-s, and I can pass s to it. Let's see what is going on. Okay. Expecting a comma delimiter, line 1, column 5. For some reason, it is not working. I need to troubleshoot. Anyway, but this approach will work when I try to use on this directly. So as part of apply, if I say JSON.load-s, it will work, but it will throw some error which is related to dealing with null values. If you look at the phone numbers, let me say df of phone numbers. If you look at it, there are some NaN values. These are considered as floats in pandas, and it is throwing exception because of that. So we need to make sure that is addressed. For that purpose, I should be able to write a simple lambda function. Again, you need to learn a little bit of Python to understand lambda functions and all. This is where you need to be really proficient with Python. Okay, there are some essential skills which you need to learn, and as part of our course, we'll be covering those if you are not familiar about Python. Now you can say lambda pn JSON.load-s of pn. Let me define the variable as pn. Pn stands for phone number. Okay, pn. When pn is not null. If it is not null, then I want to process. Otherwise, I just want to return none. Okay. Now you see these values are changed to none, which is similar to null in SQL, if you are familiar about SQL. Okay. Now I have to assign it back to phone numbers so that now the phone numbers data type is changed to something called as Python list from a JSON string, from string which have the JSON array in it. Now the phone numbers will be of type Python list. If the phone number exists, otherwise it will be none. In the similar manner, we also need to deal with addresses. In case of addresses, I don't have any null values, and hence I should be able to use json.loads directly on address, and it should work without any issue. So for addresses, it is very straightforward. I just have to say df of address equal to df dot, not df dot, but df of address dot apply json dot loads, and here we have to pass the address to it. We don't need to actually even specify the variable, the column name, because we are applying on the address directly. Okay, so automatically on the each and every value in data frame in address column, this loads function will be applied, and it will be converted to Python dict object. Now let me run this. Now if you review phone numbers, and this is nothing but Python list. If you review address, each and every value in the address column is nothing but Python dict. Originally, we have these in double quotes because it was a string with a JSON in it. Now that string with a JSON in it is converted to a data structure called as Python dict. Okay. Now we have to come up with appropriate functions to explode this data into individual columns. When it comes to address, when it comes to phone numbers, it has to be exploded into individual records. So there are two things. Phone numbers is a JSON array, and it is changed to Python list. And in a typical structured format, there should be separate record for each and every phone number. When it comes to the address, it have 4 fields, and we might want to see data related to those 4 fields as 4 separate columns. As of now, if you look at the number of columns in a data frame, we have 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 columns. And if you want to look at the number of rows, we have 10,000 rows. Now, when we explode 4 numbers, definitely it will be more than 10,000. When it comes to exploding address into multiple columns, the number of columns will be 8 plus 3 if we drop address and replace that with these 4 columns, then it will be 7 plus 4, which is 11. So the number of rows should be definitely higher than 10,000 because we have multiple phone numbers for many leads. When it comes to columns, it should be 11. Okay, so how to achieve that? So again, you need to be familiar about pandas related approach. If you want to deploy it as a Lambda function to process the data, because the data volume is lower. Okay, with Spark, the solution will be simpler compared to this one, but you should not use just Spark because the solution looks simpler. Spark might not be the appropriate candidate if the data volume is not very big. Okay, so that being said, now I should be able to define a variable by name df underscore exploded. Okay, equal to df dot explode. So there is a function called as explode in a which is exposed on a pandas data frame. For that, you can specify the column which you want to explode. In this case, it is nothing but 4 numbers. Because I am exploding 4 numbers and creating separate record for each and every 4 number, I would like to rename the column also. You can actually use something called as rename, and you can pass what is the original column name, which is nothing but 4 numbers. What is the new column name you want to use, which is nothing but 4 numbers. Okay, now you can run this. It will take care of creating this new data frame by name df underscore exploded. If you look at the data, now you see the 4 number is exploded into multiple rows. Now, if you look at the number of rows by using shape, you should be able to see both number of rows as well as the number of columns. Number of columns are still 8, but number of rows are 24,764. Okay. Now we can also use with a very simple function called as JSON normalize, which is available on top of data frame. And we can pass the df underscore exploded to it in the form of list of records. Okay, so let me show you what I'm talking about. So df underscore exploded is of type data frame. It exposes a function called as toDict. Using toDict, then by saying orient equal to records, you can create something called as list of dictionaries where each element will have the original data. You see here. So once you have this list of dictionaries, then you can use something called as JSON.normalize, and you should be able to pass this list of dicts which are generated from pandas data frame. And now if you look at it, it have generated additional columns. The number of columns are 11. But there's a prefix by saying address to all those 4 columns. We might want to rename these columns. Okay, now let me first assign it to a variable df underscore normalized equal to, okay, you have 11 column data frame now. You can review by running shape on it. However, I would like to remove those address prefixes from those 4 columns. I don't want to use them while writing it to a target. So here you should be able to get the column names and manipulate the column names using simple Python code. Okay, you just have to be familiar about Python code, about how to manage the collections, and you can take it further. So as of now, the columns look like this. We should be able to get the column details by using this piece of code. I would like to remove these things. So the way you can develop the logic is by going through each and every element, using a dot as the separator. If we have dot in any of these things, then I would like to only get the string after the dot. Rest of the stuff I want to exclude. So for all these 4 columns, we have address dot before the column, and hence we should be able to develop logic saying if the column name starts with address dot, then only pick the characters after the dot. But there's a possibility that you might end up having multiple columns with JSON strings in them, and you might end up having multiple prefixes like this. So the approach which I have specified earlier might not be a viable approach if you have not only address as a prefix but also some other thing. Another way of addressing this is if the column name have dot, then pick the one which is after the dot. Okay, and the logic can be implemented in this manner. I can say df underscore normalized dot columns equal to. Okay, one more thing, don't worry too much if it is getting complicated for you in your head. It will take time for you to digest this information. As part of our courses, you will slowly and steadily learn these things. Once you are comfortable with dealing with the metadata using a few APIs related to Python lists and dicts, these will be fairly straightforward. And also as part of the project, also you will get some time in dealing with these things. As long as you can visualize and say, okay, this is how I can implement the solution, you should be able to crack the interviews also. Sometimes you might have to go through coding tests. When it comes to coding tests, you have to be really familiar about these techniques. Otherwise, you will struggle clearing the coding tests. That being said, now the way I will start is like this. If len is nothing but the number of values in a Python list. It will give you the number of values in a Python collection. In this case, these strings I am trying to split using dot as delimiter. Okay, when I split with dot as delimiter, if number of elements that are there as part of the list is 2, okay, assuming there is only one level of JSON columns, I should be able to use this logic. If that is the case, then I have to get the second element from the list. So I can actually again use the same logic. If this condition is true, here I'm using something called as Python ternary operator. Okay, ternary operator will look like this. You have to provide the logic which is supposed to be executed when this condition is true before if, and then you will have else here. And you can actually specify whatever should be executed if this condition is not satisfied. If this condition is not satisfied, which means there is no dot in it, then you can just say else call. Okay. Otherwise, you have to get the second element, which is nothing but of1. Okay. What we are trying to do is this one. I am actually saying yes, a equal to address dot street. Okay. Now a dot split with dot as delimiter have returned something called as Python list. You can see it have two elements. By saying of1, I'll be getting the second element, and that is what I'm doing it here. Okay. However, it is complaining because call is not defined yet. You just have to say for call in df normalized dot columns. You can just copy this and paste here and run this. Now, if you look at the data frame details, it will be whatever we want to have in it. Okay. Now you see the address dot is gone from street, city, state, and also postal code. Once you get the data frame like this, you can use a function called as to_CSV. You can specify the S3 location directly. So in this case, the S3 location is nothing but S3 colon / A retail gold SF leads, then addresses, then addresses.csv. This is the name of the file which I wanted to use. We typically don't hard code the names of the files like this. We will generate the names of the files and write, but for now, to keep it simple, I'm hard coding it. However, if you look at df underscore normalized, it also have index. You see here 0, 1, 2, 3, 4. These are all nothing but index values of the data frame. By default, a data frame will have index. So while writing to CSV, you can actually say index equal to none. It will make sure that the index is not written into the CSV file which is going to be generated. Now we should be able to run this. Once again, I'm not writing any code to write the data into the file. Everything is abstracted under to_CSV. It will take care of writing our data into the CSV file without we worrying with opening the file and writing the data into the file and closing the file, which can be a little bit cumbersome. Okay. However, this is a simplified approach. If the data volume is larger, still we might be able to use Lambda function, but we might have to deal with the data in chunks. Here, I'm not going into those details about how to deal with this data in chunks, but in standard applications, we'll deal with this data in chunks, and we'll also log whether the chunk is loaded successfully or not into a file. Again, as part of our courses, you will be learning about those advanced features also. Okay. Now we need to validate whether the file is uploaded to S3 or not. Let me copy this. Let me go to the terminal. Okay. Now let me say AWS S3 ls, paste, hit enter. You can see the file. Now we should be able to use AWS S3 CP to copy to the local file system, so that we can preview the data. Let me say dot. It will be saved as addresses.csv locally. Now let me open this file. You see, we have ID, first name, last name, email, gender, IP address, phone number, street, city, state, postal code. And also when it comes to the phone number, we have only one phone number, or probably we might have none. You can see there are none values here, empty strings here. This is how you should be able to get your semi-structured data into a properly structured format. From here, you want whatever you wanted to do, you can do. Okay. So as of now, we have gone through this part, getting data from semi-structured into structured using Lambda. Okay. Once you get into this format, then we should be able to take care of running the reporting queries on top of data directly, or we can copy into the Redshift table and we can take it further. That being said, now let me go to my AWS account and let me show you how it is implemented as Lambda. Already I have created a Lambda function. you can see the example here. The code is almost same. Only thing is I made bucket name as dynamic so that if you pick up this code, you should be able to run it without any issues once you are part of the courses. Okay. You just have to deploy this and then set some environment variables and you can take it further. Whatever I have demonstrated as part of our as part of the Jupyter-based environment in a local file in local VS Code, which I have set up on my Mac. The same logic have gone here, but there is something called as Lambda handler because this is how the Lambda functions are supposed to be deployed. And if I run it, you can see that it is running. You can see it is successful. The data means whatever we have ran in the local Jupyter-based environment, the same thing have ran, and the same the existing file would have replaced with this new file which is generated by this because we are using the same hard-coded name here. If you look at the name of the actual file, we are using the same name, and hence it will be writing to the same file name. Now, if the data volume is larger, then you have to use the EMR approach. Let me also walk you through the details about how we can come up with the solution using EMR approach. So far, if you are feeling good about the content or the workshop, feel free to raise thumbs up. Please click on the like button. And also, if you haven't subscribed to my channel yet, please do so. Definitely, you will be gaining a lot of knowledge like this in the workshops which we are going to conduct in future. Okay. And also, moving for before going forward, let me actually take few questions here. I wanted to take towards the end, but if there are any important questions, I would like to take the questions here also. Okay. So there's a good question from Anubhav. I will take the first question. Second question, I will talk later. Okay. Can't we integrate AWS EMR and Lambda function? We typically don't do that, but as part of the pipeline, there might be a scenario where you might end up using the Lambda functions to do some validations around the files. Once the Lambda function validate whether the files are landed into the S3 in bronze layer or not, then you can create the pipeline. I mean, you can invoke the creation of EMR cluster, then add a step to it to deploy Spark SQL script or PySpark code application, then terminate the cluster. So yes, using AWS step functions or Airflow, you can develop the pipeline where AWS Lambda functions will perform whatever they're supposed to perform, and then go to the EMR. Okay, but for the same solution, for example, for this processing of Salesforce leads data, it will not be a good idea to club the Lambda and EMR. I don't see a reason why you should be clubbing them. So you always need to keep in mind, you always need to separate the validation of the metadata and the business logic on top of our data. You have to separate those things. When it comes to validating the metadata or dealing with metadata, we should prefer using Lambda only because we'll be managing on a very smaller data set. Okay. For example, before even getting into processing the data, let's say I would like to see if all the data related to Salesforce leads are ingested into bronze layer or not. That validation should be done only by using Lambda. Okay. Now, if your data that is ingested is larger in size, you can use another Lambda function to, you can use EMR to process the data. But if your data is not very larger in size, even you can implement the business logic as part of the Lambda function, the way we have done today. Okay. So that's how these all will coordinate. I hope I have clarified your doubt, Anubhav. So, Ronak, these questions you can always reach out to our support@itversity.com email, and they will walk you through the details. Okay, so if I go through these questions which are related to sales, then the effort related to dealing with workshop will be diluted. I'll be covering few details towards the end of the session. After that, you can actually follow up with us over support@itversity.com. Now let me actually go to YouTube and see if there are any questions. There are few questions. Yeah, where can I get all these notes and parts for this course, sir? I have completed Masters of Technology. I want to grab the opportunity to be a business analyst in India or anywhere. Can you please help me with the notes? Okay, this is not relevant at this juncture. I will answer these questions later, mostly relatable. I don't know, Maximus Zoro, I think he's just a spammer. Anyway, that's fine. So that being said, I hope I answered your question on above. If you have any follow-up question, you can post it and I will try to answer at a later point in time. Okay. Now let me actually get into the EMR approach. Let me actually search for the EMR here. Now I already have a cluster which is up and running. Okay. Now I need to pick this. I have to go to the terminal. SSH-i /.sh, then AI AWS mini.pem, Hadoop at EC2 blah blah blah. So Richard is asking, can one learn DE alone? Yeah, DE means you have quite a few things which you need to learn, Richards. You have to be comfortable with Python, SQL, then cloud. So there are quite a few skills which you should be comfortable with to become a data engineer. Okay, and you can go back to yesterday's session and today's session, and I have covered quite a lot of details about what is data engineering, what are the key skills that are supposed to be learned by anyone who want to be a data engineer. Now I am connected to EMR cluster. Already I have a script. I will just walk you through the script. Okay, the script is nothing but sfleets_transform.sql. Now, if you look at the script, let me open using VA editor. You can also configure your Visual Studio Code against it. Okay, let me also show that real quick so that you don't need to worry too much about these black screens, because some people are very apprehensive about these black screens. Okay, so when it comes to Visual Studio Code as an IDE, there's a concept of remote window. Okay, so let me first open the configuration file. You have to spend some time initially to configure this. Now let me paste the DNS alias here. So all these things will be covered as part of the course. If you are stuck somewhere, especially if you are a guided program user, our team will coordinate with you in live sessions, and we address these issues in timely manner so that you are not handicapped in these technical challenges. You can focus on key skills. Now, when it comes to the host, I can say SF leads dev cluster. Okay, now let me save it. Now let me click on this, connect to host. Now let me actually go to SF leads dev cluster. Now using Visual Studio Code, leveraging something called as a remote development, we are actually connected to the masternode of the EMR cluster. Now I should be able to open the file, which I have shown you using terminal by saying open. Okay, and this is the one which I was showing earlier using view. Now let's click on open. You see, these are the two statements which will take care of creating something called as temporary view. And then you see the logic here. If you look at it, I'm actually getting the phone numbers exploded. First, I'm converting the phone numbers, which is of type string, into array of string, so that I can use functions like explode. I will also demonstrate step by step in a moment. On top of it, when it comes to address, I'm just using from_JSON to interpret the string which is there in address as JSON and convert it to something called as the struct type. Okay, so when it comes to Spark SQL, we have data types such as array, struct, etc. Once you convert those to array or struct, then you will be having quite a few additional functions which you can leverage to do whatever you want. Okay, so now let's start with this. If you look at this logic, what we are doing, we are pointing to the S3 location where we have data ingested by Airflow, which have phone numbers in the form of string, but each phone number is nothing but JSON array, or it is null value. When it comes to address, it is again a JSON object, but it is represented as string in our original dataset. And here we are just specifying the location using path. Because our data have header, we are saying header equal to true. So spending some time and understanding the characteristics of the data, whether it is a file, text file format or some other file format. If it is text file, if it have header, what is the delimiter? What is the escape character? All those things come handy while coming up with a piece of command which will actually create a view for you. Because it's a comma separated file format, we are saying CSV here. Because data have header, we are saying header equal to true. Info schema means depending upon the data types of the values, it will automatically determine the data type. If the first column is number, it will be treated as number. If it is a string, it will be treated as string. So info schema equal to true will actually apply relevant data type of those values. Otherwise, everything will be interpreted as string if the data is being read from the CSV file. On top of it, you don't need to worry too much about enclosing character unless if it is different from double quote. If it is a double quote, then you can ignore. There is another property which is nothing but enclose. In case if your enclosing character is not double quote but something else, you can say enclose equal to whatever character that is being used to enclose. When it comes to escape, it is a double quote. If you don't specify, it will use backward slash as the escape character or some other character as the escape character by default. In this case, I wanted to explicitly say double quote as the escape character because that is the escape character for our data. So by using this here, we are not specifying any column names. We are not specifying any data types. By just specifying the location and specifying some of the properties based upon the characteristics of the data, it will be able to interpret and create a view for you. It is similar to an external table, if you are familiar about external tables in a traditional RDBMS or traditional data houses, right? So now let me launch the terminal here. Then let me launch Spark SQL. First, I'll be running this code separately and show you the results. And then I will actually run it as a application also. Okay. Now Spark SQL is being launched. Okay. Now I'm just running this. It will create the view. Okay. The problem is here I need to replace sc.bucket with actual value. So I made it parameterized. That's why it is failing. The way I can solve this is it's very straightforward. I don't need to update the code. I just have to say spark-SQL-d. Then s3.bucket, whatever name I have used as part of the script, I have to specify. In this case, the bucket name is nothing but a retail. Now let me hit enter. See here, if you observe, to just launch Spark, it is taking quite a lot of time. And by this time, you should have processed at least 500,000 or 1 million leads. Okay, so using Spark for low volume data is not a good approach. It's a very ineffective approach. Okay, now let me say set s3.bucket. I'm just seeing whether the variable is passed or not. You see it is passed. Now I should be able to copy this and paste here. Now you see view is created. I can say DESC addresses. You see, ID is of type integer because we have info schema equal to true. If you don't have info schema equal to true, even ID will be interpreted as a string. Okay. If you look at phone numbers and address, they are of type string because we have string type only, but that string is a well-formed JSON array or a well-formed JSON object. You can actually validate the phone numbers by saying select phone numbers from addresses. You can see the data in the phone numbers. I should have used limit 10, but it have displayed everything. Let me make sure I only use limit 10. I use limit 10 and see only 10 records. Now we need to make sure we interpret as array because it is of type string. Now we need to make sure it is converted to array. How to convert this to array? If a string type column have JSON data structures like JSON arrays or JSON objects, then you can use a function called as from_JSON, which is made available to you by Spark SQL. The first argument is supposed to be the column which have the JSON data structure. The second argument should be the data type of it, in which it is supposed to be interpreted. So in this case, it is supposed to be interpreted as array. Array is of, again, Spark SQL data type. It's one of the special data types in Spark SQL. You can actually specify what every element in this array represent. In this case, it is nothing but string. All phone numbers are nothing but strings, and hence we can say array of string. Now, if you run this, the phone numbers will be interpreted as array of strings. From the output perspective, you might not see much of a difference except having a space here, but not having space here. But now you should be able to use functions like explode and all on top of it to explode these into multiple rows. Okay. You can also create a view and you should be able to check the type. The data type will be array of string. Okay. Now, in the similar manner, if you wanted to convert your address into relevant type in Spark, which is nothing but struct, you need to understand how to interpret as a struct type, and you have to take it further. And you can see the logic here. I don't want to spend too much of time to type, okay? Because our address have 4 fields, which are nothing but street, city, state, and postal code. We are considering all of them as string type, and hence we are specifying string here. Struct means it is one of the special types in Spark SQL, which actually have a nested table kind of thing. If you are familiar about PL SQL in Oracle, we have a concept of nested table. It is similar to that. Okay, and you just have to use the appropriate schema here to interpret address, which is in string format, to convert it to struct type. Now, let me actually pick this one. Let me first pick this one. Okay, and let me remove explode here, just to make sure you understand the schema. Okay, phone numbers. Now let me say create or replace temporary view addresses underscore temp. Yeah, just to create a view and check the schema of the phone numbers and address. Okay, let me copy this. Let me paste here and hit enter. Now the view is created. Now if I say describe addresses underscore temp, you can see phone numbers is of type array of string, whereas the address is of type struct, which contain 4 attributes. They are nothing but street, city, state, and postal code. The data types are nothing but strings here. This is how you should be able to convert strings which have JSON structures into Spark SQL specific data types. Once you have Spark SQL specific data types, you should be able to use the relevant functions and do whatever you want. In this case, we are trying to explode, and then we wanted to make sure even the fields are separated out. So the way you can actually separate the fields is like this. Once you have addresses like this, automatically it will discard the address dot. It will not have when it is written to CSV. That's why I'm not again doing anything fancy here. It will automatically take care of it if I'm not wrong, but we'll see. We'll try to use this and we will see how it will look like. Okay. First, what I'm doing is I'm copying this piece of code, which is there as part of this select statement. And let me clean this up because I wanted to execute as script and eventually it might impact us. Okay. Now let me actually say limit 10. Let me hit enter. You see the data here. Yeah, this one also we need to explode into different columns. There is a way to do that. I will show how to do it. When it comes to phone numbers, you see it have exploded into separate records. You can also say select count of star from, then paste it. It should be more than 24,000 records. It is giving 22,218. I don't know why the number is reduced here. Let me first actually check the count from addresses. Yeah, we have 10,000, but we have only 22,218. I know why. Here I need to make sure I use explode underscore outer. So there are quite a few records where there are null values in the phone numbers. Those are discarded. That's why we are seeing only 22,218. However, when it comes to the CSV file, which is generated by Lambda function, it have more than 24,000 records. Let me show you what I'm talking about here so that it is clear for you. Where is it? Yeah, this is the project. Let me close this. Here you see it is 24,764. However, here in this Spark SQL session, it is only returning 22,000, which means there is some issue with the logic. It is because I am using explode, not explode underscore outer. When you use explode, all those records where phone numbers are null are discarded. Now, if I say select count of star on this, you should be getting the same number what we have seen using our Lambda function. So select count of star from whatever query we want to use to explode. This time it will give the same number what we are seeing, what we have seen with the Lambda approach. You can see here 24,764. However, the column names are not as per the expectations. Only thing I need to do is this one, select. Let me say from. Then I have to select this. Now I can say ID, first name, last name. Then email, then gender, then IP address, then phone number, then address dot star. Address dot star means we'll get all these exploded as multiple columns. First, let's validate. For that, I'm just copying this, then pasting here, then saying limit 10. Now you see all these are actually exploded separately. You can also create a view. Let me actually create a view real quick. Create or replace temporary view. Addresses underscore temp as because I wanted to show you the schema details also. For that, I have created this temp view, describe addresses underscore temp. Now you see, we have separate columns for the street, city, state, postal code, and all. Now we should be able to use this insert statement. This insert statement will take care of writing the processed data based upon this query into the location specified. Okay, it is a pure SQL approach. We haven't written any Python code. That's where I was emphasizing on low code or no code. Without writing too much of the code, using plain SQL statements, which are a little bit improvised based upon the characteristics of decoupled architecture, where compute and storage are decoupled. You should be able to come up with the solutions with ease. Okay, so that being said, I'm not going to run it now here to see whether the insert statement works or not. Once you come up with this Spark SQL script, then you should be able to run the script by passing the script name using -f. So the script name is nothing but sfleads underscore transform.sql. Let me save this. Now it is saved. Again, I'm writing to the same location. I'm not writing to a different location. I'm writing to the same location. Once it is copied, we should be able to review the data in that same location, and we can take it further. It will just take a moment to run. Now the development and unit testing is done, or validations are done. Once the development and validations are done, then we can build the orchestrated pipelines using something called as step functions. If you want to go with AWS native services, if you want to use the Airflow, you can even integrate these things with Airflow. Now it is run. You can validate by saying AWS S3LS S3:// A retail, that is my bucket name, then gold, then SF leads, then addresses. You can see the file which is generated. If you want to review the content of this file, let me go to the Jupyter-based environment here. Okay. Now what I can do is I can actually say pd.read_csv, because we are having CSV data only in that location. Now we have to specify this path. What is the path? Let me go to the other session here. The path is nothing but this one. We also need to specify the file name when it comes to pandas. We cannot just give the folder name, and hence I have to specify the folder name first, and then I have to include the file name also. The file name is nothing but this one. Here I'm checking whether we'll be able to interpret the data the way it is supposed to be from this location. Okay, I just wanted to use pandas approach for this, but you can choose whatever approach you want to choose. Now let's run this, and you can see the data, but it is not as per the expectations. I will tell you why. Okay, here if you look at the insert statement, I haven't specified the characteristics using which the data should be written. That's why it is showing a bit weird manner here. We need to make sure we address this issue. Okay, so let me go here. Here also I can say using CSV. Okay, and then options. Sep equal to comma. I don't know whether it will work or not. I haven't tested this, but we will see. Sep equal to comma, and then it is not relevant because we will not be having any escape characters. Let's see whether this will work or not. If it doesn't work, then I have to see the solution. Let me copy this. Let me run it directly from here. Spark-SQL with s3.bucket equal to a retail -f sf leads underscore transform. While it is running, let me see whether we will be able to pass the properties like that. So Spark insert overwrite directory CSV. Okay. Yeah, insert overwrite directory using options. Yeah, we can use options. So most likely it should work. It seems to be working. Now let's go here. And let's see whether this time we'll be able to see the results as per the expectations or not. Okay, the name of the file is changed. That's why it is failing. Let me go here. Now let me run AWS S3LS command. Now let's copy this. Still, it is not working. Probably I might not have saved. Let me see if yeah, that is the problem. I haven't saved this. Okay, now it is saved. Also, I wanted to specify the header because if I look at the output, the header is not there. The column names are not proper. Now let me also include header equal to true. Now let me save it. Now let me run it. Okay, what I'm trying to say is if you look at the details here, even the column name, I'm sorry, the column names at the top are not appropriate. It is because we haven't said header equal to true while writing in the form of CSV. Now, as we have said, header equal to true, most likely it should be written with header and also the separator should be comma. Read underscore CSV expects comma as the default delimiter. This time it should work without any gaps. Let's wait until it is run completely, then we'll take it further. Now let me run AWS S3LS command. Let me pick the file name. Let me go to the session. Let me replace it. Do we have CSV at the end? Let me see. Yeah, I have CSV at the end. I need to make sure I add V here. What happened? File not found. Let me check. Yeah, it seems to be right name. Then why it is complaining saying file not found? Interesting. I don't know why it is complaining. Probably there might be some special character somewhere. AWS S3 LS. Yeah. It was working earlier. Why it is not working now? Just give me a minute. I should be able to troubleshoot. I might be goofing up somewhere. Mostly it should be related to some typo. First, let me see if I am able to read this. Yeah, it is working. Gold, SF leads addresses. Then let me copy this. Let me paste here. Interesting. It is showing the file, but okay, I don't know why, but yeah, that's fine. We don't need to worry too much about it. Probably there might be some special character at the end of the file which might be causing the issue. Let me do this. Let me actually copy this file to local file system. Okay, so I can use cp command. Just to make sure we are validating, I'm just doing this, okay? Now it will create a file here. Now we should be able to say open with text editor. I think it is still downloading. And now it is downloaded. Now open with text editor and you can see the data as per the expectations. So the data is there in this file. For some reason, I think there's some goof up somewhere which is causing the issue. Otherwise, the data is written as per the expectations and we are good to go. So this is how you should be able to use Spark. Let me also show you a few pipelines about how they really look like. Okay. Now, if the way we build pipelines is by using something called as step functions. If you use the AWS native approach, if it is the cloud agnostic approach, then we typically use something called as the Airflow, and we will take it further. So to answer Anubhav's question earlier, where he have mentioned about Lambda and EMR. Okay, I have an example here. I think it is nothing but this one. Let me see. Yeah, you see here, if you go to this workflow studio, which is a drag and drop interface, where you should be able to use this and build the pipeline. Okay. Now, if you look at this, I have a Lambda function to check the number of files. So the expectation is for this project, we'll be getting one file every hour. So for a given day, there should be 24 hours. So I wanted to check whether there are 24 files or not, even before creating the EMR cluster and process the data. Okay, so that's where we have the Lambda function. As we are dealing with quite a few larger data set, in this case, we have implemented the processing logic using EMR. Once only when we get the required files into the source, then it is going through the process of creating the EMR cluster, adding step to the cluster, terminate the cluster. So even for the leads processing with respect to Salesforce data, we can follow the similar approach if the data volumes are larger. If not, we can just replace these with the Lambda function, which have the business logic to process and write to whatever target location you want to write to. So that being said, as of now, if you go back to this design, we are able to get the data to this. Now it is time for us to see whether we'll be able to build reports off of this data. Okay, for that you should be able to use Redshift. Already we have the data copied into the gold layer. Okay, the location with respect to the data is nothing but this one, even though I'm not able to read using pandas for some reason, but this is the location, right? If I'm able to create a table in Redshift pointing to this location, I should be able to read this data and do whatever I want. Okay, for POCs, you can directly use the table pointing to this location and generate the reports and dashboards. For actual production reports, because having the processed data in S3 and then using Redshift on top of it might impact the performance. In those scenarios, you can even copy the data into the Redshift table using Redshift itself. You don't need to have a EMR cluster or Lambda function also. Okay, or you can trigger the Redshift command from Lambda, which will actually get the data from S3 into the Redshift table, and you can take it further. As part of our courses, we have covered even those details. As part of the pipeline, after data is processed by EMR or Lambda, in case if you wanted to get the data into Redshift and report off of it, how to come up with the solution. There's a course on Redshift alone. In that course, we have even covered how to integrate Spark and Redshift in the form of a pipeline. There will not be direct integration, but once the data is processed using Spark SQL, the way it is demonstrated today, if this data has to be copied to Redshift, it can be copied. However, for today, we will treat it as a POC, and we will see whether we will be able to query the data that is there in this CSV file using Redshift. So lately, Redshift have evolved into serverless. So using serverless Redshift, we should be able to query the tables in S3 without much challenges. Okay, serverless Redshift means the Redshift cluster will not be up and running all the time. Whenever you run queries, only then the infrastructure will come up, process the data, and it will go off immediately. Okay, so let me click on query data here. Redshift also have a visual interface where you can write queries. Okay, and this is how you should be able to create the database against bronze data. And this is how you should be able to create a database against gold layer. So this is the one which is related to the gold layer. And these are the queries which are running against gold layer. Let me pick these things. And even this one, I have to copy all these three. Paste here, and we can take it further. However, we have just copied the data into that S3 location. We haven't created the table. How to create the table? Should we use create table statement in Redshift and create the table? Or is there an automatic way which will provide us the tables in the directional schemas which are exposed to Redshift? I'll come back to this in a moment. Even here, you don't need to, means when I say I'll come back to this in a moment, I'm talking about this creating external schema and all. First, I would like to highlight something called as glue catalog. Okay, so glue catalog will contain databases and tables which can be accessed either through Spark or Redshift or Athena. There are multiple interfaces using which you should be able to query the tables in glue catalog. However, to create tables in glue catalog, you don't need to go and manually create table for each and every dataset. You have a concept of glue crawler. If you configure glue crawler, it will crawl all the folders based upon the data and metadata. It will automatically create tables for you. Okay, so let me go to glue here. Let me show the crawlers which I have created for both bronze as well as gold layers. So if I go to crawlers here, there are two crawlers, SFLeets bronze crawler and SFLeets gold crawler. So with respect to bronze crawler, where we have this double quote as escape character, it seems glue have some bugs and it is not able to create the table properly, and I'm not able to query the data in Redshift. I just want to highlight that. But with gold, because it's a simple structured data, there are no issues. Okay. Now, if I go to edit here, and if I go to the steps, you see as part of the data store, I have specified the S3 path. And this is the path where we have written our data to. If I go back to Visual Studio Code interface, you see, I have written the data to A retail gold SF leads addresses, and you can see the CSV file also. So the same location is used here without specifying the file name. So whatever file it have, it will go to that file, and based on the metadata you have in that file, it will actually create the table for you. You don't need to sit and write create table statement. For one table, going through glue crawler approach might be a little bit overhead, but if you have 100 folders like the addresses under SF leads, you don't need to sit and come up with create table statements. And also advantage of glue crawler is periodically you can schedule and run it. If there are any changes with respect to the data structures of the files that are being placed in that location, it will update the glue catalog tables accordingly. Okay, now you should be able to click on next, then click on next, then click on next. So these are all steps which you need to follow. Again, as part of our courses, we have gone step-by-step instructions. Here I'm not going through highlight all those things. Already I have the glue crawler defined using appropriate one. Already the table is also created. The table is in a database called as SF leads gold DB. Let me zoom out a little bit. Let me delete this. As it is deleted, let me go to the crawler and let me choose SF leads gold crawler, run crawler. Now the crawler will run. It will take care of creating the database and table for us. Once the database and table is created in a glue, in Redshift, you can use that glue database, which is nothing but SF leads gold DB, and you can actually create a external schema. This is called as Redshift Spectrum. So Redshift Spectrum will facilitate you to use tables that are in a glue catalog to run queries against. You can also create Spectrum tables against S3 location using the Redshift syntax also. You can actually come up with create table statement against the files in S3, and you should be able to create table directly also. Either you can take the route of glue catalog, or you can directly create table using Redshift syntax. Okay. In this case, we'll be using glue catalog route. Let me make sure the connection is active. And now you can see that the connection is active. As part of this database, you should be able to see external schema by name SF leads gold DB. Let's wait until it comes up, then we'll take it further. Most likely by now, the crawler might have run. Let's refresh this. Yeah, you see it is stopping state. It is in stopping state, and there is one table added. You can go to the tables and you can review the schema of the table here. It is as per the expectation. Now we can go here. I need to refresh this. For some reason, it is not showing the schema. Let me run this. Probably I might not have ran it. I think I have ran it. For some reason, it is not showing. Actually, it should show up. Probably it might be in dev. Yeah. See here. Yeah. SF leads gold DB. Okay. Already the schema is created. This is how you can actually create the schema pointing to glue catalog, and then all the tables that are there in that glue catalog database, which is nothing but SF leads gold DB, are exposed here. You can review the data by running this query. You can see the data here. Now, when it comes to reporting requirements, the reporting requirements will be like this. Get me number of leads that come from each state or each city. Okay. And in this case, ID is not unique, because as we have exploded the 4 numbers, the ID is not unique. To get the number of leads, I have to use distinct ID here. So this will be giving the lead count by city within each state. This will give the count by state. Also, the data will be sorted in descending order by lead count by state. You can see the output here. So most of the leads are from California. Now, if you want to use BI tools on top of this table called as addresses, which is pointing to S3, you can actually use BI tools and configure your reports, but it might not be very efficient. You might have to copy this data. You can come up with your ETL logic by querying the data from the table pointing to S3 location and process it and write to the target, or you can also process using EMR, and the processed data can be copied into the reporting tables in Redshift, and reporting can be done off of those tables. That is how we typically build the solution using AWS native approach to visualize and get some insights on top of Salesforce leads data. Okay, if you wanted to implement using Databricks, only here and here you will be using Databricks components. Rest of the things can be third party or mostly AWS native. Okay, now this is how you should be able to take care of implementing the solution. Already we have gone through the details. Once again, I'm reiterating what is the path for ETL developers to be a data engineer. Revise your existing SQL, data modeling, and ETL skills. Enhance your SQL skills by adding serverless and ability to process JSON. Learn programming using Python, leveraging your existing ETL abilities. So you can use your ETL abilities as reference, and you should be able to pick up Python from that perspective. Master cloud essentials, especially data lake, IAM, serverless functions, orchestration, etc. Ability to process large volumes of data using distributed computing frameworks such as Spark. Understand the architectural patterns based on cloud. Ability to troubleshoot the issues, and also performance tuning. These are the things which you should pick up over a period of time, and you can take it further. Okay. Then we have guided program to be a data engineer using AWS Data Analytics at this time. We'll start with Python and SQL if you are not familiar about Python and SQL. If you're already familiar about Python and SQL, you will directly get into AWS Essentials for data engineers, for data lake, distributed compute, data warehouse, and other purpose-built services. Okay. Then you will be going to something called as mastering AWS Lambda functions for data engineers to build or enhance the data pipelines. Then mastering AWS Elastic MapReduce for data engineers, again, to build data pipeline, to process large-scale data using distributed computing. Then mastering AWS Redshift as data warehouse for data engineers. It is primarily used to build data marts or data warehouse to serve enterprise reports or dashboards. Mastering AWS Athena and Glue data catalog. Then streaming pipelines using MSK and also Kinesis. Finally, there will be modules related to performance tuning, interview preparation, etc. So these are the things which will be covering as part of the course. Now, when it comes to the cost and timelines for the course, it might take anywhere between 9 months to 1 year if you take this part-time. If you are a full-time ETL developer, to gain all the skills starting from Python and SQL, it might take anywhere between 6 to 9 months. If you are already familiar about Python and SQL, and if you are spending 15 to 20 hours every week, then you might be able to wrap it up within 4 to 5 months. Delivery mode will be hybrid. It will be self-paced with continuous support. Labs and additional, so we'll be providing labs with respect to learning Python, SQL, and Spark. But when it comes to AWS, you have to pick your own account, and you have to take care of practicing things related to AWS. So the cost might be under $100 at the max. If you cross even 50, 60, I'll be surprised, unless until you leave services like EMR for a long time. You might end up spending quite a lot of money. If you don't do that, then $50, $60 you should be able to wrap up. When it comes to the content, access to the content, you will be getting lifetime access. We have a refund policy of 14 days. We'll also provide placement assistance as well as support. And also you'll be invited to Elite Club, where we'll be building a strong community, which will involve all levels of data engineers globally. Again, okay, I think I have just copy pasted. So these are the details. In case if you have any queries with respect to cost and all, feel free to reach out to support@itverse.com. We charge $480, which include Python, SQL, Spark, and all AWS related services. If you're already familiar about Python and SQL, we charge $400. For students and for some people, we have special considerations. We'll be giving additional discounts. Just reach out to support@itverse.com, and we should be good to go. Okay. So that being said, I hope you enjoyed today's session. I will take few questions and then we'll wrap up. Before getting into Q&A, if you haven't liked the session yet, feel free to click on like button, and also make sure you to share with your friends if they are intending to get into data engineering role. And also reach out to us at support@itverse.com in case if you have any questions. If you haven't subscribed to our channel yet, make sure you subscribe and also click on notification icon. There'll be quite a few live workshops like this in future. I'll start with Rock Himalaya's question. For college student, please tell the optimized roadmap. You tell the tech stack names. I note it down. Yeah, so it's simple. If you go to this slide, even for yeah, this actually covers for anyone. So you have to start from Python and SQL, and you have to add additional skills based on the cloud which you are interested in. For students like you, for college-going students like you, we have a very cost-effective roadmap. Feel free to reach out to support@itverse.com. We'll share more details about you about it. Richard is saying Hadoop looks like Databricks. Hadoop is outdated. You don't need to worry too much about Hadoop. Hadoop have evolved into Spark and eventually into Databricks. So Databricks, Hadoop is a precursor to Databricks. And your statement is right. Hadoop will look like Databricks only. It is similar to, in Hadoop, you use Hive SQL. Whatever statements you are seeing, you have seen as part of today using Spark SQL, you'll be seeing as part of Databricks also, because Databricks uses Spark SQL. Spark SQL is flavor of Hive only. Okay. I don't think it's the issue with the permissions of the file. I don't know, Sharath. There could be some issue with the special character somewhere in the name. I will troubleshoot at a later point in time. Even for Azmat, I don't think that is the issue. Now let me take the questions which are asked by Ronak and Anubhav. Anubhav is asking, while designing an application in cloud, shall we upload similar style industry standard project structure like we are doing till now, like using unit test, integration test, logging, error handling, etc.? Yeah, those are all streamlined. You don't need to break your head about too much of exception handling, too much of logging, etc. Once you start building Lambda functions or step functions, most of the time things will be logged into CloudWatch. CloudWatch is the service which will streamline this process. You have to think about these things, but most of the times there might be out of the box solution. You just have to leverage and you have to take it further. Okay. And Ronak is asking about Udemy courses. Yeah, let me also explain difference between Udemy and this one. All the courses which will be there as part of our guided programs will be there in Udemy also. Okay. However, as part of the Udemy, they will be published as 8 to 12 courses, and each course will cost you around $40 at a retail price. Okay, but Udemy gives discounts. You might end up getting all these 12 courses within $100 to $120. But we'll only support using Udemy Q&A, and there might be 1 or 2 sessions every week where we might provide some live support. But with respect to guided program, it is much beyond that. So there is a team which is going to support all your issues. And also there will be expert sessions with experts, which include me and also someone who is already having experience and all those things. So that being said, I'll answer a few questions for those guys who are in the Zoom. But I would like to conclude YouTube, and I would like to move forward. Anyone who is on YouTube, if you have any questions, feel free to join the live session. I'll be sharing the link with you. Okay. And you can actually join the live session. I'll take a 5-minute break, and then I'll start answering your questions. But whoever is there as part of the Zoom meeting, you stay until I answer all the questions. For now, I'll be ending the YouTube live stream. Okay. Once again, I'm thanking everyone who have joined through YouTube live stream. If you see this as a pre-recorded video, and if you want to reach out to us in case of any questions, especially from YouTube, feel free to reach out to support@itverse.com. We'll be glad to answer all your questions. Okay. That being said, I'm ending the live stream now. And those who still have questions, make sure you join the Zoom meeting, and then we'll take it further.